Okay. So once again, good afternoon to everyone. So today, for our practical session, we are going to study the experiments on a simulation of a dilation and erosion. Okay. My voice is audible and my screen is visible. Okay. 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 Wait a minute. Okay. So the concept of dilation and erosion we can study it in our unit number 4. Okay. So the dilation and erosion are comes under the morphological operations on the images. So in that we can change the shape, means we can add the image, we can subtract the image. So the concept of dilation and erosion we can study it in our unit number 4. Okay. So what we did in a dilation, so in a dilation simply we can add the image, so we can call it as a dilation B, and in erosion we can subtract the image, so we can call it as a erosion B. So in our theoretical lecture also we can take a binary image, and on a binary image with the help of structuring element we can perform the dilation and erosion operation. Okay. So in our fourth unit we can perform the 4 major operations, that is a dilation, erosion, opening and closing. Okay. So by taking a simple binary example we can perform the dilation and erosion. Okay. So for dilation and erosion we consider the condition, what is a perfect match, what is a some match, and what is a no match. Okay. So based on the matching we can perform the dilation and erosion operation. Okay. So now for practical we can take the one image, and on that image we can perform the operation like a dilation and erosion. Okay. So first we'll understand the code how to perform the dilation and erosion, and then after we'll, by looking at the output, we can consider what is a change in an image, what is a dilation and what is the erosion. Okay. So now first we'll move towards the code. Okay. So now we'll understand the code by stepwise. So first step is that, okay, now when we do any code in a MATLAB, so we can use the basic commands are CLC, clear all and close all. So these 3 commands are basic commands in a MATLAB. So to clear the previous code or to clear the command window we can use these CLC, clear all and close all. Okay. Okay, wait a minute. Okay. So now understood the first part of a code. So in order to perform this operation, we require a input image. Okay. So to take input image, so simply we can take a input image, okay, and provide the its extension. So the input image is in the format of JPG. So for image, we can provide a name as a nature 1, and the extension is .jpg. So first we need to read the image. Okay, so in order to read the image, we can provide the extension as a im read, and we can store this image into the variable x. So the first line is a x is equal to im read nature.jpg. Okay, so first we can take a input. So in order to take a input, we can consider a one image which is in the format of jpg, and we can store that image into the variable x. Okay, so how to read the image? So in order to read the image, the command is im read, and we can store into the variable x. Okay, and now we have to display the image. So in order to display the image, we require the command as a im show. So with the help of im show, we can display the image. So we use the command as a im show here. So here we have to display the different various images on a single window. So that's why we can use a subplot command. So here we can use the subplot as 2, 3, 1. Okay, so it consists of 2 rows, 3 columns, and first position. So at first position, we displayed the input image. Okay, so up to it understood? Okay, so first we can simply take an input and store into the variable x. Okay, so up to this understood? Any doubt up to this? Hello? Yes, have you understood? Okay, so now we'll move towards the next code. So we'll understand this code step by step. So in first step, simply we can take a one input image and store into the variable x. Okay, so the input image is in the format of RGB. So when we simulate any code in a MATLAB, so we're not directly deal with the RGB image, because the RGB image is of a 24-bit size. Okay, and it consists of nearly 16 million colors. So there is a lot of variation in the intensity of light. So we can convert the RGB image into the gray image. Okay, so we are not directly perform any operation on a RGB image. So when we convert the color model from one RGB to HSI, so at that time we can directly deal with a RGB image. But when we perform any operations, it is addition, subtraction, dilation, erosion, so we can convert the RGB image into the gray image. So can anyone tell how to convert the RGB image into the gray image? What is the command to convert RGB image into the gray image? Yes, can anyone tell what is the command, which command we can use to convert the RGB image into the gray image? Yes, anyone? Okay, so now we'll understood the next step of a code. So in next step, we can convert the RGB image into the gray image. So in order to convert the RGB image into the gray image, so we can use the command as RGB to gray. Okay, so here our input image is stored into the variable X. So now after the conversion, when we convert the RGB image into the gray image, so that image we can store into the variable A. Okay, so same image we can display it by using a IM show. Okay, so now we'll run the code up to the conversion RGB to gray. Now everyone focus on your screen. Okay, so have you observed the RGB image and a gray image? Okay, so in first step, we can take up one input image which is in the format of RGB. Okay, so that image we can convert into the gray image. Okay, now we have to move towards the next code. Okay, so here we have to perform the two types of operations. One is a dilation and another is a erosion. Okay, so simply we have to perform the addition and a subtraction. Okay, so when we perform the addition and subtraction, so we have to consider only the binary image. Okay, so now everyone listen carefully. So similar in our theory lectures also, when we perform the dilation and erosion, we can take a example of a binary image. So the binary image consists of only two colors, it which can be represented with a 0 and 1. Okay, so when we perform the dilation and erosion operation, so we need to convert the gray image into the black and white image. Okay, so why we convert the gray image into the black and white image? So when we deals with the dilation and erosion operation, so the dilation erosion operation can perform only on a binary image. Okay, so we need to convert the gray image into the black and white image. So why we can convert into the black and white image? So it consists of only the two colors. One is a black and another is a white. That is, we have to convert into the zeros and 1. Okay, so similar to the RGB to gray, so in order to convert the gray image into the black and white image, the command is, so everyone focus on a command. So the command is IM to black and white, that is a BW. Okay, so everyone focus on a highlighted part. So by using this command, we can convert the image into the black and white image. So the gray image is stored into the variable A. So we can convert the gray image into the black and white image and we can store into the variable B. Okay, so have you understood how to convert the gray image into the black and white image? So simply the command is IM to black and white, that is IM to BW, and the gray image is stored in the variable A. Okay, so we can display this black and white image with the help of command as a IM show. Okay, so now we'll run the code up to the step number 3. Okay, so everyone focus on output. Okay, so in step number 1, we can take an input image. So input image is converted into the gray image by using RGB to gray. Then the gray image is converted into the black and white image by using the command im to bw. Okay, so up to this understood? Yes, up to this code, any doubt? Okay, so now we can perform the dilation and erosion operation. Okay, so everyone focus on the code of a dilation and erosion. Okay, so we have to perform the first dilation operation and then a erosion operation. So what is the command to perform the dilation operation? So everyone focus on a command. So the dilation and the erosion are the morphological operations. Okay, so we can study it in our unit number 4, morphological processing. We can call it as the various morphological operations, which are dilation, erosion, opening and closing. So the dilation and the erosion are the morphological operations. So here the command is, so we can use a C variable to store the dilation image. So the command is bw morph. Okay, so bw morph, so in bracket, so here we store the black and white image. So we store the black and white image into the variable b. So here we can use the variable as a b comma dilate. Okay, so by using this command we can perform the dilation operation. Okay, so now we have to show the dilation image. So in order to show the dilation image, we can use the command as im show. Okay, so similar to this, we have to perform the erosion operation also. So it is a command. So similar to dilation, we have to perform the erosion operation. So here we can use a variable as a d. So the d is equal to bw morph b comma erode, erode. So by using this command we can perform the erosion operation, and after this, to display the image we can use im show. Okay, so now we'll run the entire code and observe the change in output. Okay, so again, in a step by step we'll understood the output. So at the first step, what we did, so simply we can take a one input image. So our input image is a RGB image, and which is in the format of JPG. So we can provide the extension as .jpg. So at second step, we can convert the RGB image into the gray image. So by using the command as a RGB to gray. Now we have to perform the dilation and erosion operation. So we can perform the dilation and erosion operation on a binary image. So for that, we can convert the gray image into the black and white image. So by using the command im2bw. So after that, we can perform the dilation operation and erosion operation. Okay. So observe the output of dilation and erosion. Okay, so by using this simple code, we can perform the dilation and erosion operation on any image. So everyone observe the output of dilation and erosion. Okay, so this is a simple MATLAB code to convert to perform the dilation operation and the erosion operation on a input image. Okay, so we cannot directly perform the dilation and erosion operation on a color image. Okay, so for that, first we can convert into the gray image, and after that we can convert the gray image into the black and white image. Okay, so have you understood the code? Yes or no? Hello? Okay, so any doubts? Okay, so by using such a simple code, we can take a one input image and we can perform the dilation operation and erosion operation. So in order to perform the dilation operation and erosion operation, we require the only binary image. So what the binary image consists? So it consists of only two intensities. One is a black and another is a white. So first we need to convert the input image into the black and white image. So by using step-by-step operations, first we can convert the RGB image into the gray image, and then after we can convert the gray image into the black and white image, and after that we can perform the dilation and the erosion operation. So what is a dilation? So dilation simply addition, and the erosion means simply subtraction. Okay. Yes. Okay. So here we can perform the simulation experiment on a dilation and erosion. Okay. So if you have any doubt, you can ask here. Okay. So if not, you can put your attendance.